Hey, Luca. Great to see
Hey,
you. Hey.
great to see
Uh,
you.
yeah, you're the last of the speakers today, but it doesn't mean the least. So I'm great to have you with us. I know we are a little bit delayed, but it's also about that knowledge sharing and the discussion. That's why we have to stay a little bit longer with Alex, for example. But before letting you in, just let me briefly introduce you because you're really huge enthusiast of the serverless. As a chief technology officer at the Neosperience, you build highly scalable, but you will introduce us to that scale in few minutes. A highly scalable environment with millions of the requests. But I also know that you write on Medium about the serverless and machine learning, where you focus around CDK, SageMaker, Lambda. So, like I said initially, you are a strong enthusiast and you like to share with that, but you can expand that idea more. Last but not least, I'm super happy because you're also the co-founder of a serverless meetup in Italy and co-organizer of serverless days in Milano in Italy. So great to have you with us, and the floor is yours.
Thank you. Thank you very much. Thank you all for having me. It's a pleasure. It's an honor to be here. It's an honor to speak at several days because it's just one kind of events that we started. And I think that a couple of years ago, we started something huge and it's growing even better from year to year. So with no further ado, let me introduce my session. I'm going to talk to you about the lessons we learn, and we learn that in the hard way, about how to handle millions of events coming into your serverless architecture. Just a brief introduction about who I am. I am Chief Technology Officer at Neosperience and at Witsky, and I am the proud co-founder of Serverless Meetup Italy and Serverless Days co-organizers. For our Italian-speaking folks, we are having an event next Saturday on the 23rd in Milano. So if you are there, if you want to jump in and say hello, you are more than welcome. Then you can find me on GitHub, LinkedIn, Twitter, and our social channel. And I also pleased to be AWS community builder and AWS serverless hero. My passion is related to serverless and machine learning. So this is the reason why I work at my company building with my team a customer analytics solution. We build a lot of products, but right now I want to talk to you about user insight, which is one of them that face the most challenging demands, the most challenging requirements. And it is related to the fact that this product ingests events coming from the browser. So any click or tap or scroll or any time that you spend on an image can be ingested and it becomes an event. But stop talking about the products of my company and start talking about the problems that we have to face and why we develop and we evolve the architectures, trying to face them and trying to build something capable of handling these events. Events are coming from the browser and events are generated by a standard JS library. It's exactly the same approach that many other great tools such as Google Analytics or any kind of analytics takes. So you have a library that you drop this JavaScript into your client, into your web page, and it starts sending the events down the stream down to the backend. And an event holds a bunch of data. To our understanding and to our purpose, we had to split the events into three kinds of different events, what we called low-level events, which are basically the events that directly are tied to the browser, so click, scroll, tap, and whatever. the mid-level events, which are events that are related to web page actions, and they are domain specific. So if you are using the library into an e-commerce portal, we generate an event when you put the item into the cart or when you pay for the item. And high-level events that are highly customer specific. So 3 kinds of event, but basically the same structure. The event type, the timestamp is just a small JSON payload that you have to ingest and that you have to handle. But the constraints are really challenging. The first constraint is related to response time. When we started this stuff, we did not have WebSockets, and we needed to support even older browsers. So we had to use not only WebSocket, but also beacons, which is a technology supported by web browser to package and send pack of data in the background. Then the volume of the events can grow really quickly and with unpredictable patterns. And if you consider that different customers are using the same platform, which is served as a SaaS service, you can easily reach millions of events within a single month, but also hundreds of thousands of events per second. And this can be huge, and this can be really difficult to handle, even if you scale up your architecture very quickly. And the other problem is related to the throughput, because events could peak, because maybe one of your customers is having a Black Friday special deal, and they are sending you 3,000 or 4,000 events per second, or 10,000 events per minute, and you have to handle them and to handle all of them across all your customer base. So we needed to build a pipeline to ingest events. And I'm not repeating again why we choose serverless, because we needed to be elastic, we needed to scale up and down, and we needed to be reliable. And a lot of great speakers today talked about the reason why serverless is the answer to this question. But I'm here to talk to you how we build that. And so we started with drawing our pipeline, our data processing pipeline, and we understood that we needed to ingest events, then collect them and send them to a storage in order to decouple them. Then after that, we needed to apply some kind of ETL techniques, and down the way, we had to manage and extract meaningful insight from them automatically using machine learning, using automatic processing, using statistical models, and then store all the events into an aggregated customer profile, because at the end of the day, the only thing that is meaningful for our customer is to understand a bit more about their customer. So we can divide this pipeline into 3 main moments: the ingest phase, the convert phase, and the analyze phase. And the ingest one is the most challenging, because it's hidden by the huge number of events that are sent through the pipeline. So down the way, you can decouple. You have a number of techniques that you can use to decouple events, to decouple throughput. But at the first step of your endpoint, you are being hit by this huge number of events. So the first phase related to ingesting the events, we focused on this kind of pipeline, and we started to ask ourselves which could be the best architecture to achieve that, to do that. And we started with the standard, basically server standard architecture, which is API Gateway, then a Lambda function, and finally a database. And even starting with this, we had some trouble in choosing the right persistence model, the right database. We started considering our serverless, which is great, but before the release of serverless 2.0, it has a ramp-up scaling time of a few seconds, and it was not acceptable to us to manage that. Then we started considering DocumentDB, which is great to store nested documents, but it is not the right choice. if you have small JSON or small JSON payloads that needs to be stored in a huge amount, in a huge quantity. And this took us to the first decision to use DynamoDB. DynamoDB is great. It's able to handle millions of events with a single-digit millisecond response time, but we discovered that we were using DynamoDB not as a key value store, not as a fast cache database, but as an analytics database. And this was a problem. This was a problem because we hadn't in our mind a clear access pattern when we started using DynamoDB, so we weren't able to build the right indices to pull the data out from DynamoDB. And it is a huge problem if you have within a single table for a single customer more than 60 gigabytes of events generated in just 1 month. And if you don't have a clear data pattern, you are doing a lot of scan requests, and it is not the best and the cheapest way to use DynamoDB. So we started reworking our architecture, and we started considering something different, something else. And we opted for S3 as our final endpoint, our final storage. It is great because it's an object store. You can store directly JSON payloads. It has high availability. It is multi-AZ, and it is designed to handle a huge traffic for any kind of internet application. And moreover, it is cost effective. But the other problem was how to stream to S3. We detected up to 5K records per second in our use case, and so we decided to adopt it, to use Kinesis firehose because it could handle that massive throughput. And it also had support for data buffering to decouple input to output, and we could also deal with partition and store with partition. And just a quick takeaway, please choose your partitioning scheme wisely, because if you need to use other services down the way, the partitioning scheme is not irrelevant. Choosing a poor or a not compatible partitioning scheme means you need to rework, you need to reprocess the huge amount of data. We chose that scheme because it was compatible with the standard of partitioning scheme that Spark is used to manage. So our architecture evolved to API Gateway, then Lambda, then Kinesis, firehose, and S3. But we discovered that we had few problems related to looking into our Lambda function, because remapping our events, so taking our events from the gateway and unwrapping them and then sending them down to firehose presented issues that can be detected looking into the matrix, because looking at the matrix, we had sometimes spikes about the error count. So our lambdas were failing. They were not able to deal with this huge throughput, with this huge amount of data when it was hitting our endpoint. And moreover, we discovered that we had a huge number of concurrent executions and some spikes that could be difficultly undetectable. And focusing on that, we discovered that the massive amount of errors that we faced, it was related to Lambda scaling up or Lambda ramping up. And we had a couple of alternatives to manage that, and also to support this invocation pattern within the Lambda. But we remembered kind of mantra that it is deeply stated in the serverless world, which is to use Lambda to transform data, not transport data. And basically, the thing that we were doing was transferring data from the gateway to S3 to firehose. then we improved our architecture in order to remove Lambda cold start issues, and we could use provision capacity, but we preferred just pulling the Lambda service out from the equation and directly connecting API Gateway to firehose in order to maximize the throughput of our architecture. And this is great because using the direct connection from API Gateway to firehose, you are able to directly invoke firehose, or if you want to remap any kind of attribute within your payload, you can use velocity templates where they are not super developer friendly, but they are great and it works perfectly into matching the data and mapping data payloads from one payload to another payload. And even we could use API Gateway to validate the events that were coming to the endpoint. But let's talk about the events. So event types, as I told you before, there were three kind of types: low level, medium level, and high level. And not all the types needed the same throughput. So basically, we started to implement some kind of fan-out strategies. The first one was related to splitting the events, so pushing the events not directly to firehose, but through Kinesis data stream, and then using Kinesis analytics to switch the pipeline and send that events, the low-level events, into firehose and then to S3, and then the medium-level event as well. And finally, the higher-level events, directly process them into Elasticsearch. So this allowed us to improve the kind of pipeline and also the workflow for these events without requiring us to pull high-level events, which are in a low number compared to low-level events, without requiring us to pull them out from the data lakes, but just having them directly into Elasticsearch. And there is you can find how to map Kinesis data stream to API Gateway in the AWS docs guide, developer guide, and then there is a great project on GitHub by Alex Casalboni about Kinesis stream fan-out patterns and how you can implement them. And that was basically the idea, but we wanted to do more because considering that we split the three streams of data processing, we could also move things earlier and then use rules down after the gateway in order to detect which event should be mapped to what service. This resulted into dispatching events using velocity templates, or you can use SNS if you prefer to dispatch events. And then we could map the type attribute of the event to the right stream into the right pipeline. And this meant that we could also pool Kinesis data stream, which has a fixed recurring cost, and insert SQS. We couldn't be able to use SQS before that because of the huge, massive amount of events that we needed to process with low-level events. But if we are decoupling, if we are splitting the events before deciding which workflow we want to use, it is more than feasible. Then we moved to the convert part, which was basically a massive glue script able to extract data and to build user session out from that data. This is an example of the script. We are not going through that, but the most interesting thing is that it's starting from S3 and then it ended to S3 and glue data catalog. So we were able to consolidate events even with user IDs, user session IDs, into data catalog, which helped us a lot into processing this data with Athena, because having the user IDs avoided us to build a complex Athena query that could hit the 30-minute processing time. So managing and transforming events with Spark, basically, which is done by Glue, was a great addition. And finally, we were able to implement the data analysis stage using data loaded into the Glue data catalog, then Athena to build customer queries to extract customer insights. And we were also able to expose the SQL-like syntax of Athena to our users in order to allow them to not only use predefined queries, but also to build new queries that they could need for their use case. And it was great also because we were able to integrate within Athena also the invocation of Amazon SageMaker, because you can use custom functions within an Athena query in order to use a machine learning model, and also to invoke a Lambda function if you need, and to complement it to provide the results for the query. And afterwards, the insights were pulled to Elasticsearch in order to be made available, to be processed further, and also to be queried from Elasticsearch. That meant that we used Amazon Athena to build the customer insights and to consolidate the customer record, and then the resulting insights were stored into Elasticsearch. This means that we had to run a huge number of Athena, but the great thing is that even processing 500 gigabytes with Athena is just a matter of a few minutes. And it is something that you can run in batch mode and then consolidate the data into Elasticsearch to be queried real time. So putting all together, this is the user insight, the data pipeline that we managed to build in order to offer to our customer the possibility to deal with such massive amount of data. And so this should end my presentation, but I want to introduce one more thing that it was helpful to us, and we released on GitHub. It's just a pet project that I built in my free time, and we are using that actively. It is IAM Policy Generator. As Piotr talked a couple of hours ago in his talk, one of the main caveats into ensuring that you are bounding security into the thing that you do is to shape correctly the policy of your IAM roles. So this is our library. It is taught for CDK users that allows you to use the IDE IntelliSense in order to build a policy statement. So feel free to check that out, send me comments. I'm willing to understand how I can improve that library, and I'm looking for fellow contributors to bring the library to many more people. So thank you all. Here's the link, the QR code with the links. If you want to reach out, I will be more than happy to answer your question, to start a discussion, and to get in touch. Thank you very much.
Thank you, Luca. Have we got any questions on the chat already? Let us check. No questions. So in the meantime, maybe some will come up. Luca, thank you very much for your session. But I got a question to you, because you presented quite a complex scenario. I mean, it's not a single Lambda API gateway and database. There are some tightly related components that have to be really properly defined. But what I would like to ask about is the security. How do you deal with the security in such scenario? Because this is one factor and kind of obstacle for people that are entering serverless world. That's, yeah, I can build this scenario you presented, but if I'm not responsible for that security, or maybe I have to change the way we are talking throughout the day about the shifting our mindset in around the serverless. And is it the same with the security? How do you think? How do you deal with that internally?
Yeah, I think that you have to bring all the concepts coming from security experts and try to understand which best practices can be applied and how to apply them. Just to give you an example, when we started using S3 as our data lake, we have to build a lot of guardrails in order to enable ACL or detect data being exploited or manage access control with that. And we decided to use lake formation in order to have a bunch of starting point for that. But definitely we needed to be able to focus on the specific kind of attacks and payloads that could arrive to our data lakes, even because the endpoint that we used, unfortunately, being an endpoint that it is hidden, that is invoked by the browser asynchronously, we could not provide anything other than an API key. So we didn't have any kind of strong authentication mechanism to be put in place. So we did have to do the work downway in order to secure that after the first endpoint that could be hit by a huge amount of problems, the problem didn't propagate to the rest of the architecture. So you can send basically anything you wish to that endpoint, because this is the constraint that the browser is forcing us to deal with, but we need to cut that off and secure the data from that point on.
And is it their responsibility to closing that thread? Because I see that we get a question from Cornelius. So to closing that thread, is it in your team the responsibility of the developers, or you move that out to some external department? I mean, DevSecOps or whatever we call that.
Yeah, we try to have autonomous team, so we try to enforce that responsibility to the developers, because they know the kind of software, the kind of logic that they need to implement. We experienced a lot of friction between different departments. So if you need a security expert, probably that security expert should be in your team and working with your team since day one, because otherwise you are wasting a lot of time into shifting knowledge from the business logic and the security people.
Excellent. I mean, that's what I thought. Moving out the experience outside the team, yeah, it's not always, definitely not always a good decision. So thank you for answering that and expanding the idea a little bit more. Like I said, we got a question from Cornelius, so maybe I will read that loudly for the audience, and you can think over the response, Luca. How did you maintain the native integration between API Gateway and Kinesis Firehose? Because you presented it already. I mean, the Velocity template language code itself. Was that just string interpolation and hard coding, which is hardly maintainable, unfortunately, Cornelius said? Or did you hide that behind some well-thought Velocity template builder you've created? Thank you, Cornelius, for your question. And Luca,
if I could have a penny for every time I was asked this question. Luckily to us, in my team, we had a lot of experience with Velocity templates, because one life ago, in 2010, we used them to customize the answer from the backend to the mobile devices. So we know them pretty well, but we still have problem dealing with that, because it is difficult to test. So we wrote a utility, an internal utility that simulates the request coming to a fake service implementing the template, using the template to match that, and we checked the result downwards at the end of the processing. So it is just a velocity template tester that we built. The great thing is that we were also able to detect error in the templates in production, because the kind of payload that we used was exactly the same kind of payload that it is pushed to S3. It is pushed to the endpoint. So we just needed to read the events, replay the event through the events to our tester, and then check which of them were failing to be processed. So this basically was our approach. I know that velocity templates are not the best thing if you want to start mapping things around. Another option that we consider was using SNS. It probably could be for some folks even a better option, because you are totally in control of what happens in your system.
Yeah, definitely velocity template is pain in the ass, literally.
Yeah.
Whenever,
It's love and hate. You love them when they work, and you hate them, and you hate the world when they don't.
Yeah, there should be a sign, love me or hate me. And definitely 90% of the people would say, okay, hate that. It's really tough to deal with that. But I totally understand. And Cornelius, thank you for raising that topic, which is pretty critical, because we all deal with that while dealing with API Gateway as something behind. So yeah, thank you very much. Guys, if we have any more questions, if not, Luca, glad to see you, glad to have you on the stage. Thank you very much for your effort, because it's always an effort to prepare and to present. So thank you very much for your time. Take care, and once again,
thank you very much.